5 is 0.5.
Well, no, I'm saying figure out the energy from 0 to 1.0 and then subtract that 62.5.
That's exactly how you do it. Because you can't just say, well, I'm going a half a meter and use the half a meter, because that would give you the answer for this one. We know this one's going to be less than this one. So we know how much energy that spring, you basically have to say how much energy has it at this point, how much energy is at the next point. The difference between the two is how much it is to go from half to 1. So we've already done the first part of this. So we're going to work it again. Energy spring is 1/2 times 500 newtons per meter squared. Times 1 meter. You say it's 250?
Yeah. Half of 500 times 1.
Okay. So the difference is what? 137 point? No. 187 or something like that? Is that right? 187.5? Pops in my head.
That's pretty good.
Yes, something like that. That's not the energy in the spring. That's the, I guess we just call it the delta, the change in energy. Or we could also say it's the work that we put into the spring. So it's about 3 times as much. So even though the force is linear, the amount of energy to keep going, it keeps hard. It grows exponentially. Okay? So it kind of makes sense. I mean, y'all have all worked with springs. You keep going, they keep getting harder and harder and harder. And just ever more work to keep compressing it. Up to the point where you get permanent deformation, then it can start getting easier again. So this only works when the spring is in a non-permanent deformation mode. Talk about another form of energy. This one y'all may have seen before. Kinetic energy. I want to put that little bill in there. That's supposed to be 1/2 mass times velocity squared. Some of y'all seen this before? In a physics class or something like that? Let's do the same thing. Let's just work the units and make sure we're going to get units of energy out. The 1/2 doesn't have any units. Mass, that's kilograms. That's a meter per second squared. So you've got kilogram, meter squared, second squared. So what are we trying to get to? Kinetic energy, what's that? Energy is not a Newton. Energy is a joule. Energy is joules, work is joules. Always. SI units. Energy and work are both in joules. So ultimately we want to get over here to, this is our target, is joules. Let's look at it from this side of it. What's our other definition for a joule? We break that one down again. Newton meter. This is looking more like a Newton meter than a joule. So let's try converting this, and we need the Newton in the numerator. So the Newton is a kilogram meter per second squared. That's our definition of a Newton. Remember that? A Newton is a kilogram meter per second squared. I wrote the same thing right here. Second squareds cancel. One of our meters cancel. Our kilograms cancel. What's left? A Newton meter, okay. And that is a joule. But units do work out. Makes sense. So let's work a problem. I'm on the order of, we'll make it easy. I'm on the order of 100. No, kilograms less than, no, yeah, 100